Okay, so I'm going to do this one on the calculator. Researcher claims, there's your claim, that 51% of the U.S. adults believe incorrectly that antibiotics are effective against viruses. Okay, so their claim is that the proportion that believe incorrectly is 51%. Okay, since that's what they believe, that 51% of the Americans believe incorrectly, it contains equality, so that is the null hypothesis. All right, the opposite of being 51% is not being 51%. That's not containing equality, so that's the alternative hypothesis. In a random sample of 2,202 adults, 2,202 adults, and they say that the ones that believe are 1,161. So we'll have to calculate p hat. P hat is the number who believe over the total number in the sample. So 1161 divided by 2202. And we get a p hat of about 0.53. This is 2 decimals, so I'm going to do this one to 2 decimals, so about 0.53. Okay, so now we've got an alpha of 0.01. It's pretty bad. My Z value. This is a two-tail test, so we're going to have shading on both sides. Okay, so the area under here is going to be alpha divided by 2, which is 0.05. Got 0.05 right here. We've got 0.05 over here. And the total shading is 10%. So that means that this part in here is 90%. Not that it matters, but anyway. So we need a critical value right here. We need a critical value here, and this will be the same critical value. It's just going to be positive. And we can find that by doing using the calculator. This is an inverse norm area, so we can get our critical value right there, or you could also always look it up on the Z table. Since it's a part right here, this is probably going to be the answer right here, because it is a two-tail test and 90% in here is shaded. So that means that a total of 10% is not shaded. So even though this is not a confidence interval, the two-tail test, we could still use this table. But also if we come up here and look, 1.645, 1.645, halfway in between that, you'll see is where we'll find this is 0.0495, really close to 0.05. And this one's 0.05, a little bit greater. So we can see that 1.64 and then halfway between these two would be 1.645. So it's going to be, so we were right that number is going to be your critical value. But since this is a video on calculators, we can come over here and we're talking about a distribution here. So you can do second vars, and this is an inverse norm because we know the area and we're looking for the z-score. The area that we have is 0.05, so that was put in there last time. If you don't have this calculator, then if you have an 83, then this is what you're going to do, inverse norm, 0.05, comma 0, comma 1. Press enter, and it gives me negative 1.64, and then we would round that up to 5. So we have found the critical value. So this is negative 1.645, and this is positive 1.645. Now we need to find the test statistic, and the test stat is going to be found on the calculator. That'll be z equals something, and we're also going to get a p-value. Okay, so we're going to, whoops, that's not what I want. We want to grab the calculator, and this is a statistics test, a hypothesis test. So we'll find the testing under the stat button. So you hit stat, and then you click over to test. This is a 1 proportion z-test. So we're going to choose option number 5. And they want to know what the p-value is. So the p-value is what we have up here. It's our claim. That's always going to be our claim. P sub O, that's going to be our claim. So it's going to be 0.51. And then how many people said yes? 1161. And how many people were there in the sample? And what was the alternative hypothesis? Not equal to. So we're going to save that one. And we're going to calculate. And our z-value, our test statistic, is 1. I hate it when it goes away. 1.62 or 619. 1.62. And our p-value is this one right here, 0.1054. 0.1054. 0.1054. Okay, so we can answer now this question. We can either decide to reject or fail to reject H sub O. And we're going to do that by plotting the test statistic. So I'm going to change this and plot this. This is 1.64. So 1.62 is going to come right before that. That's 1.62 is right before the 1.645. Since it is right before, then this is not, it's not in the shaded section, so this is the fail to reject section. And since we failed to reject the null, then that's what we're going to look up on our little table. Now, the other thing that we could do is compare our p-value to alpha. Our p-value is 0.1054. Our alpha was 0.10. Now, this is, if we were just comparing those first two numbers, they would be the same, but this has some numbers afterwards, or you could say, well, this 5 would round that up to 11. So this p-value right here is bigger. And when p is bigger than alpha, what do? When p is bigger than alpha, we fail to reject. So with both situations, we fail to reject. All right, so now we need to draw our conclusion. So we need two things. What was the claim? The claim was your null. The claim was the null. and we failed to reject the null. So on our little chart right here, this time I don't even know how to erase this. So this time, I got to figure out how to erase this. On this time, the claim was the null and we failed to reject. So this is the answer this time. So there is not enough evidence to reject the claim. There is not enough evidence to reject the claim. There is not enough evidence at 10% significance level to reject the claim that 51% of adults believe incorrectly that antibiotics help a virus. Okay, so that is using the calculator. Again, what did we do? We do stat, we go to tests, and for when it's a proportion, we do a one proportion z-test. You have to be able to read it and figure out how many people are in the sample. That always goes on bottom. How many people believe what the claim is, or are agreeing with the claim, or give the same results as our claim. That's this number right here. That number always goes on top. Remember, the number on top should always be smaller than the number on bottom, because you can't have more people responding than is actually in the sample. So this number should always be smaller than this number. And then you divide it out. If they give you this, then you multiply this times the sample size to calculate this. Okay. Let me know if you have any questions.